So good morning to everyone. So in previous classes we discussed about phase lock loops and triple five timers. So in this class we will start a new concept, that is conversion, analog to digital conversion and digital to analog conversion. So this is a new concept, entire new concept. So it is one of the important and major applications of linear integrated circuits, especially in the conversions, especially in the conversions, even in the electronical circuit perspective, or whatever it may be the constraint. So electrical circuits plays linear integrated circuits plays an important role in this analog to digital conversion and digital to analog conversion. So what is the perspective of application, and what are the wide range of applications involved in this type of conversion? So that needs to be highlighted and that needs to be discussed here. So at this chapter, new module, in the concept of A to D converters and D to A converters, so we will discuss about what are the main highlights. We discuss means we will discuss about the exact introduction. So the introduction involves about the objectives. The introduction involves about the outline synopsis of analog to digital converters and digital to analog converters. And next we will discuss about various classification of this conversion configurations. So how, in what particular configurational point of view, a digital pulse is converted into analog pulse, or a digital signal is converted into analog signal by using a weighted resistor type digital to analog converter, or by using a particular R to R ladder type analog to digital converter, by using an inverted R to R analog to digital converter. So here we will propose a new integrated circuit, that is series 1408 digital to analog conversion. So with respect to digital to analog conversion, the title clearly suggests we will also discuss about digital to analog as well as analog to digital. That means in a parallel manner. Okay, in a sequential manner also we will discuss various conversions from analogs to digital and digital to analog. So here we will discuss about parallel comparator type ADCs, counter type ADCs, successive approximation type ADCs, and dual slope type ADCs, and DACs, and various specifications of integrated circuits. So here, what is the main objective, or what is main important role, plays a vital role. So how can we involve this type of configurations, or how can we evolve this type of applications in our integrated circuits means? So mostly these are called as data converters. So how can we use the term data converters means? Here what's happening means, the pulse, analog pulse, is converting itself into digital. Sorry, analog pulse. Sorry. So the analog pulse is converted into digital, and the digital pulse is converted into analog. That means that makes the definition the concept of data converter, or the objective of data converter. So if we see what is the objective, if we discuss in this introduction perspective means, mostly in a point of view in the real world applications, here the voltage, current, temperature, most of the things are available in a analog form. Most of the times, most of the things are available in analog form. So even the representation of these quantities, physical quantities which we talk. So if we take an electrical physical quantities, so what are the electrical physical quantities? Voltage, current, temperature. Okay, so there are various types of electrical physical quantities. Power is an electrical physical quantity. So if we take a normal physical quantities like temperature, pressure, and all other things, so most of the time they available in a analog form in nature. So even there is an analog form. So in order to measure the signal performance in the analog form, so we have to be precise and we have to be accurate. That means the signal which is present in nature in an analog perspective, signal which is available in nature in an analog perspective, signal which is available in an analog perspective plays an important role, plays a vital role in the measurement and making the accuracy. The perspective is very, very important, and another most important thing is accuracy. In an accuracy point of view also, The representation of a measured signal has to be maintained, and there's no that need to be transmitted or processed in a particular manner. That means here what we are going to discuss means here what we are going to discuss means here the measurement of analog signal, the transmission of analog signal or processing of analog signal or eliminating the noise from the analog signal plays an important role and plays a vital role in the in the concept of data converters. So here what we need to do means our most important priority of the objective is accuracy, providing the accuracy in the conversion from analog to analog pulse to digital pulse or digital pulse to analog pulse is the utmost objective. So here what is the main purpose? How can we maintain accuracy means by using proper methods or by using proper configurations or by designing a proper configuration of data converters, we can clearly provide an accuracy. Okay, and the noise rejection of the signal will be eliminated, and the transmission of power, mostly the transmission of power and processing of power, here it plays a very crucial role and create it will plays a very vital role. So here how can we eliminate this by type of noise signals means by processing the signal. So we need to process the analog signal properly before converting into the digital pulse such that the noise will be eliminated. And after why we were continuously focusing on eliminating the noise means this noise will affects the accuracy of the signal. This noise will affects the discrete nature of the signal. So by eliminating this noise component in a particular signal, the accuracy perspective will be improved, and so these type of conversions will be quite accurate and feasible. So this is about the objective discussion. This is about the main objective of this chapter, analog to digital converters and digital to analog converters. So what is the main objective? So here what is the main objective means here we are proposing the concept of data converters. Okay, the main purpose of data converters is to convert the physical nature, okay, or the physical nature of a quantity or analog nature of a quantity into digital quantity by eliminating the noise, by processing it in a particular manner to improve the accuracy and precision of the signal. That means before the analog signal is converted into digital signal, that has to be smoothened properly, and it should be smoothened properly, and the signal nature has to be improved in a perspective manner. So if we see the block diagram point of view here, so see, look at the block diagram point of view here. In the block diagram segmentation we can clearly observe how the conversion is going to happen. So this is a peculiar application where we can use for analog to digital conversion and as well as for digital to analog conversion. So the perspective of analog to digital conversion and digital to analog conversion is related with respect to data conversion. The objective here is clearly suggests the concept of data conversion. In the application of data conversion, here we can clearly shown the concept of data conversion in the block diagram which we have chosen here. So in the concept of this particular data correction, see, so here we can explain the block diagram, the representation of block diagram. So this is a general schematic. So the most of the highlights with this typical application with respect to analog to digital or digital to analog conversion is analyzed with respect to an analog signal. Analog signal is obtained from the transducer band. First, the analog signal is applied from the transducer band is of limited by an anchorizing filter. So this anchorizing filter, with this particular anchorizing filter, the signal obtained from the transducer is band limited with this particular anchoizer. So the signal is then sampled with respect to frequency rate more than the twice with respect to the maximum frequency of band limited signal. That means the sampling signal has to be held constant while conversion is taking place from analog to digital or digital to analog conversion. This requires mostly at this perspective the ADC should be preceded by a sample and hold circuit. A sample and hold circuit, the ADC is having a peculiar sequence of binary conversion. Peculiar sequence of binary conversion, mostly the main object of the binary digit. That means the microcomputer or the digital signal processor performs this numerical calculations which we are talking up to a desired control algorithm. That means the digital to analog converter is to convert mostly the digital signal into analog signal and function of the digital signal, the DAC. The objective is to limit the opposite nature of ADC. That means the digital to analog converter is operated at a particular same frequency as of analog to digital converter. The output of digital to analog converter is analyzed in a staircase manner. So this staircase manner, if we observe the staircase manner, most of you are familiar with respect to this type of staircase digital output, which is passed mostly with respect to the smoothing the signal to reduce the effect of quantization. To reduce the effect of the quantization. So the analysis of the block diagram, the basic analysis of this block diagram, either it is a digital to analog conversion or from that analog to digital conversion, plays an important role, plays a vital role. So how this going to happen, we see here. So we have taken the analog pulse with the help of a sensor or a transducer, what we are talking about. That means the transducer or a sensor will take the analog signal, and next that is passed to the analyzing filter. So the filter, what does the filter do means, this filter will act like a band limit filter, not band reject filter, band limit filter. Band reject filter is different from band limit filter. So the next that is forwarded to the sample and hold circuit in order to convert the analog, in order to observe the discrete nature of the analog pulse. That means that the transducer which is collected, transducer or the sensor which is collected the analog pulse, in order to observe that analog pulse discrete nature, it is next forwarded to sample and hold circuit, and next it is analyzed with respect to analog to digital converter. That means here at this instant, the analog pulse is converted into digital pulse. At this moment, of data conversion, the discrete analog pulse is converted into discrete digital pulse. Okay, and next that is forwarded to a digital signal processor. So what does this type of digital signal processor do means, this digital signal processor will absorb the discrete digital signal, and it will convert that into a discrete it will convert that into a digital binary signal. So at this moment, what has happened means, the conversion of analog to digital is completed. Analog to digital is completed. So see means how the analog pulse is converted into digital pulse. How the analog pulse is converted into digital pulse. The analog pulse is observed with respect to, see, observe very carefully, listen very carefully. This is very important concept, and this objective of converting analog to digital to analog is analyzed in a single block structure. This is very crucial in our explanation. In coming configurations, this plays a vital role. This plays a very important perspective. So see here, the sensor or a transducer collected the analog pulse from the plant. Collected the analog pulse from the plant and is next forwarded to the filter, anti-aliasing filter. It is also called as band limit filter. And next, in order to observe the discrete nature of the filter, we have forwarded the signal with respect to sample and hold circuit. And next, that is analyzed with respect to analog to digital converter. This analog to digital converter, what it will do means, it will convert the discrete analog pulse into discrete digital pulse. Okay, the entire conversion is not yet done. After converting the discrete analog pulse into discrete digital pulse, next it is forwarded to digital signal processor. That digital signal processor will convert this discrete digital pulse into discrete binary signal. At this instant, the analog pulse is converted into digital pulse. So this looks like a somewhat cascaded mechanism. You know what, most of you are familiar with respect to the cascaded mechanism. What is a cascaded mechanism, or what is a cascaded approach means? So next, what is our application is converting of digital signal into analog signal, conversion of digital signal into analog signal. So how this going to happen is, the digital signal is converted next with respect to a digital to analog converter. That means whatever the digital signal processor converted the discrete digital binary signal, that digital binary signal is taken as an input with respect to digital to analog converter, and next that is for converted, that digital binary signal is converted into a staircase signal, that is converted with respect to a staircase signal. So that means the staircase signal is having certain amount of rampness and the various perspective with respect to the rampness and all. So with respect to that rampness, what will happen means, what will happen means the rampness of the signal, it has to be smoothened, and that noise has to be eliminated with respect to smoothen filter, and next that staircase digital signal is for that staircase signal is further converted or further smoothed in the form of an analog pulse. So this is how we analyzed, this is how we analyzed the digital signal into analog signal and analog signal into digital signal. So in a similar manner we explained the block diagram. So next in a configurations, before going into configurations, so first we have to see how this digital to analog converter and analog to digital converter is done, or how this type of techniques are analyzed means. So various techniques we propose here in the perspective, various techniques we propose here in the objective point of view. So before going into discuss this type of analysis here, the digital to analog technique is analyzed here. So look at this type of block diagram. So in this point of perspective, we are proposing a basic DAC, we are proposing a basic DAC. So digital to analog conversion. So how that going to happen actually? So in the block diagram we have seen, the block diagram we have analyzed the digital to analog conversion and analog to digital conversion. So the basic technique of the digital to analog conversion is given the input digital binary code, and it is combined with a reference voltage signal, and it will produce a voltage signal in the form of voltage or current signal if the output of the signal is voltage. See here, what we are going to analyze means, here the digital to analog conversion is given with respect to an input digital binary code, and it is combined with respect to a reference voltage. See in the block diagram, in the block diagram, and that with the help of the reference voltage we are converting the input voltage into, we are converting the discrete binary word into an output voltage with respect to the signal in the signal perspective. So before going to analyze this perspective, if we see the analysis point of view, if we see the discrete analysis here in this topic of digital to analog conversion technique. The topic of digital to analog conversion technique, see here what is actually happened means, here the output voltage V0 is observed here, the digital pulse, that means the binary digital segmentation, what we have seen here, the binary digital segmentation is converted into analog signal. That means here in the concept the digital pulse is converting into analog pulse. So how that is going to happen, how the digital pulse is converted into analog pulse. So what is the perspective here means, so the binary digital code or the binary digital pulse is given as input here in the MSP's most significant bits and least significant bits. Most of you are familiar with this type of digital electronic language. We studied in digital logic design and digital electronics, we are familiar with this. And that binary code or the binary signal, digital signal in the form of most significant bit d1 to the d1 d2 d3 dn minus 1 dn least significant bit, with the help of the reference pulse we are connecting that into an output. So how that going to happen, how the analysis perspective is happened means, the basic concept or the basic technique of digital to analog conversion given with respect to even with respect to the binary code is combined with respect to a reference voltage, and that will produce the output signal in the form of a voltage voltage, that means in the form of an analog voltage or in the form of an analog current. That means here, if we analyze the output signal, the output signal is an analog signal. The output signal may be in the form of voltage, or output signal may be in the form of current, depending upon the reference quantity which we used in the conversion point of view. We processed the digital code, digital signal, with the help of a reference voltage pulse, and the output we observed is voltage signal. So how that going to happen? V naught is nothing but output voltage, and K is nothing but a scaling factor. VF is nothing but full scale output voltage, and we all know D1, D2, D3. D1 is nothing but most significant bit, and DN is nothing but least significant bit. So this is nothing but a general perspective of digital to analog conversion. So if we analyze in a various aspects, if we propose various aspects of digital to analog conversion, there are various aspects of digital to analog conversion, like weighted resistor type digital to analog conversion, R2 or ladder type digital to analog conversion, inverted R2 or ladder digital to analog conversion. So these are the various factors are involved in this type of digital to analog conversions and analog to digital conversions. So if we propose the weighted resistor type digital to analog conversion, okay, so what we have done means, again we have used an operational amplifier. A negative feedback type operational amplifier is used in the concept of digital to analog conversion. So what is our objective? Our objective is to convert a digital binary signal into an analog pulse. Either it may be converted into voltage quantity, or it may be converted into current quantity. So the first configuration is weighted resistor type digital analog conversion. So this is a combination of using active elements and passive elements. Why I am talking about the combination of using active elements and passive elements means, so if we see the perspective here, active elements or passive elements, whatever it may be. So the weighted resistor type digital to analog conversion is used by constructing an operational amplifier, negative feedback type operational amplifier, and a series of resistors are connected with respect to inverting terminal of the operational amplifier. See, most of you are familiar the terminals of the operational amplifier. Operational amplifier used to have 5 terminals, 2 input terminals. Negative terminal is inverting type terminal, positive type is non-inverting type terminal. Okay, and here we have two biasing voltage terminals I haven't shown, and output voltage terminal is V0, and a negative feedback is provided here in order to provide proper actual gain. Okay, so if we see this particular construction of weighted resistor type digital to analog conversion, so if we see this perspective, it looks like a inverting type operational amplifier. Why I am saying inverting type operational amplifier means a series of resistances. A series of resistances are connected with respect to inverting terminal of the operational amplifier. That makes the configuration look like a inverting type operational amplifier. So this is about the circuit structure. With respect to negative feedback, the resistances MSB, most significant bit D1, D2, D3, least significant bit DL. These type of resistance are connected with respect to non-inverting type resistance in a parallel manner, in a series manner. So if we analyze this particular circuit diagram in a theoretical concept, so the DAC type weighted resistor DAC type, which is one of the simple circuits we have analyzed, that uses the configuration of summing amplifier with a binary weighted resistor. That means, so here the electronic switches D1, D2, D3 and Dn are controlled with respect to the binary input word. So these switches are nothing but looks like a single pulse double thrown SPDT type, which we most of you have seen these type of switches in our laboratory point of view. So if the binary input of a particular switch is 1, okay, so it will connect the resistance with respect to reference voltage. And if the input bit is 0, the switch will connect the resistance to the ground. The output current is analyzed with respect to the perspective point of view. That means here if we analyzed the concept, here, see here, we analyzed the concept here. So the resistances are connected with respect to the non inverting terminal in a summing amplifier type configuration. And next, each resistor is connected with respect to an SPDT switch. Okay, most of you are familiar with respect to the SPDT switch. And next, what we have done means, so each switch is connected with respect to binary segmentation. So how we can say the switch is on and how we can say the switch is off means, if the switch is connected to if the switch is connected to the one segment, see here, this is one. So if we connect the switch at this particular instant, the resistor is applied with respect to the reference voltage. If we tap the switch with respect to the ground, it is referred with respect to 0. If we connect that to 1, it is referred as application of reference voltage. Same will happen to the series resistance. If we analyze the circuit in a mathematical nature, so after analyzing the KVL here at this particular node, so this is nothing but inverting node. This is nothing but the inverting node of the operational amplifier. So if we apply the KVL here, sorry, if we apply the KCL here, what is the behavior of currents here? The currents I naught is equal to I naught, which is nothing but the current flowing in this path. I naught is equal to I1 plus I2 plus I3 plus IN. So after observing the behavior of currents, so if we apply the current division rule with respect to the voltage, what is the behavior of current with respect to the voltage? Okay, with respect to the digital switch D1, D2, D3, so this is nothing but current digital volt. So D1 is nothing, D1, D2, and so on up to Dn is nothing but least significant bit, and D1 is nothing but most significant bit. So this is nothing but the behavior of voltage to resistor current division rule. So if we simplify further, I naught is equal to V into R divided by R into D1 by R1, D2 by R2 plus D3 by R3, so on up to Dn by R. So what will be the output voltage? Output voltage is nothing but a combination of input current, that is I naught, into reference into feedback resistance. Feedback resistance is termed with respect to RF. V naught is equal to V is equal to IR. That suppose V naught is equal to I naught into RF. So if we substitute the value of I naught here, I naught here with respect to RF, this is the final perspective of output voltage. The perspective of output voltage. So if we analyze here, what are the important points which we discussed with respect to the weighted resistor type digital to analog conversion means, so the above circuit which is proposed in an inverting configuration, it is also possible to operate in a non-inverting configuration also. We just designed the circuit with respect to the inverting configuration. It is also helps us to analyze with respect to non-inverting configuration. Okay, so but instead of using this, why we are using the inverting type configuration means, so if we provide a positive reference voltage, that depending upon the type of the switch, so the operational amplifier will starts converting into current to voltage converter, So this is a nature of the output graph depending upon the tapping of the switch. So whenever this is nothing but input to digital code, that is 001 So this is the input code with respect to analog signal. So there are various drawbacks also. There are some drawbacks also. One of the most important drawback is depending upon the bit size which we have chosen. So that is the bits we have chosen is the digital binary input code. So this requires a large number of resistance which need to be fabricated in integrated circuit. So that is one of the major drawback. There's a major drawback. So this is the concept which we discussed today. So in today's class, what we have discussed means we analyzed the objective of analog to digital conversion and digital to analog conversion. We explained the concept of data converters. Okay, and next we analyzed about the block diagram. And next we discussed about the technique of digital to analog conversion, and we explained the first classification, that is weighted resistor type digital to analog conversion.